Hello everyone, welcome back to another project, and this script MATLAB project that actually perform demand response analysis for 4 homes. It uses the data from data underscore base .m file, which include the load and generation data to simulate energy management, including battery storage, grid interaction, and energy sharing. Let's start the detailed breakdown of the code. First, let's start with the data underscore base .m file, which include all the data which we have to perform right over here. This script file that actually this file include two matrices, load and generation. Let's start with this one. These matrices actually represent load, demand, and generation supply data for a system like electric grid or similar network. Here, if we start with the generation matrix, which is here. This is the load matrix. This is the load matrix, which actually represent the load data for 10 different loads, which each load represent one column across 48 time steps or scenarios, which actually are the rows. Each column represent the load type, and each row represent the scenarios. So total are 48 scenarios, and there are 10 columns which represent the 10 different type of loads. For example, in the first row, load 1 has a value of 1, and load 6 has a value of 5, and load 7 has a value of 9. Now let's move into the generation matrix. So this matrix represents the generation, which shows the generation from PV and wind profiles. So the purpose of this matrix represent the generation data for 10 different generation sources. Each source represent in a column across 48 steps or scenarios. So each row correspond to a specific time step or scenario, and each column correspond to a specific generation sources like PV1, PV2, wind 1, and the wind 2. So what will be the possible use case? This script is used to store and organize data for further analysis or simulation. The load and generation matrices are used in the in this file. This script file, which is based on MATLAB, that performs the demand analysis for the 4 homes using the data which we stored in this data underscore base file. Let's start with the clear commands, and then we are just considering the data which we have right over here, and then we have considered grid capacity right over here, and then we started our SOC section. So the maximum SOC, maximum state of charge for batteries in each home, and similarly the minimum state of charge for the batteries. And then there is a SOC, a matrix to store the SOC of the batteries for 48 steps or for 48 scenarios, and 4 columns which represent the 4 homes accordingly. So initialized to 2 minimum SOC, and set to 6 at the first time step. And then there is LOD, which purpose is to compute the net load by subtracting the load from the generation for each time. And next, this section, which start from the line number 12 to 32. So this section purpose is to manage the battery storage system for each home based on the net load. So if we start from this point, if the net load is negative, means we have excess generation, the battery is charged. If batteries are allow it to charge them. And if the net load, the second scenario, if the net load is positive, means excess demand, the battery is discharged if batteries have a capacity, or if batteries are allow them. And the next, which is the PESS, stores the power exchanged with the battery. And there is one more variable, which is right over here, this variable TLOD, total net load across all the homes for each time step. And there is a variable which is GR, which grid power required when the total net load is negative. So that's how we calculate all this stuff. And let's move into the next phase. So this is basically the calculation for energy sharing calculation, starting from H to this line. So this section calculates the total energy shared. We represent this thing with the H, and the grid energy for each home, which is represented by the GH. And next, there is a section for the results and visualization. So this is the next section, which represent the results and visualization for all this process. So CH, which computes the total charge, and the DIS, which is the actually a discharge of the batteries. So the result combine the net load and grid power into a single matrix of display. And then there is a start of the plots, which actually include the load generation and batteries power over time, grid import export over time, and battery state of charge over time, which I will show you at the end when I run this MATLAB program. So if I summarize this project, and at the end of these displays and the labeling the figures right over here. So this is the demand response result, which H1, H2, H3. So this section actually displays the results in a tabular format, including net load and grid power for each home. And then there is a bar plots, which are starting from here, this section. So this section include the bar plot, which actually visualize the total energy exported and imported by each home using bar plots. So let me run this program. Let me click on run here, and here you can see all the outputs. If I can show you here. So the dr underscore 4 home.m script simulate demand response for 4 homes using the load and generation data from this data underscore base.m file. It manages the battery storage, calculates net load, and determine energy sharing with the grid. So here you can see the total export and total import. Here you can see the import and export to the all the homes. There is one more home here, and similarly here you can see the home and import and export for all the figures. So the script is useful for analyzing energy management strategies in a multi-home system with renewable generation and the battery storage. And if I show you through the command section of this program, here in the summary result, here you can see that the database.m file provides the load and generation data which we have considered earlier. The results are displayed here, the total load shared by homes, total shared by the grid, load shared by the H1 to H10, and load shared by grid to home, and all that stuff are mentioned here. So I hope you like this video, and please subscribe the channel and press the bell icon so you don't miss any next upcoming projects. And thanks for watching.